Let's take a look at Project 1, Section 3, Question 1 for Algebra 2B. Just a reminder, again, these videos are meant to be supplementary and I don't include all the context that is provided for you in the project. So if you haven't already, please read the project or read along, have the project open as you go through this video. So we are moving on from our air conditioning problems and we're working on a type of problem commonly referred to as a work problem. In this case, we're talking about optimizing a painting job. When we talk about work problems, we're talking about rational equations or functions. Hopefully that's a hint. You've encountered them before. They're of the template, if person A can paint a fence in 2 hours and the person B can paint a fence in 4 hours, how long will it take them to paint the fence together? Those are called work problems, and that's what we've got here. We're talking about two different painters and the time it takes for them to paint a dining room together and the time it's going to take for them to paint a ballroom together. What we're going to do is figure out a system of equations to represent the text that is described here. Okay, we're going to find a way to condense all that information in that paragraph into a pair of equations, a system of equations. These questions are things we're going to work on answering throughout this section. For now, we're just focusing on this question in white. So with that being said, let's get started. All right, so a servant says he knows it will take X days for the first royal painter to paint the dining room if he works alone. All right, so it's going to take X days. Beautiful. And it will take Y days for the second painter. It'll take Y days for the second painter to paint the same room for himself. If the painters work together, they can paint the dining room in 12/7 days. All right, so that was all about the dining room. Next, and I'm just going to cut it right there, next they talk about a different room. But I'm going to stop right there and work on this first equation, okay? Because they give us a relationship about how long it's going to take each painter to paint the room and then how long it's going to take them together. So each equation is going to represent the time it takes to paint a particular room. So again, these videos are meant to be supplementary. I'm not going to go into too much minute detail about work problems here, okay? I'm just going to help you get set up. So if it takes me X days to do something, I don't want to talk about, well, it takes me 2 days to do something. I want to talk about what fraction of the job can I get done in 1 day. So if it takes this painter X days to paint this room, then he can get 1x, 1 over x of the job done in 1 day, right? So another way to think about this, say that I said it'll take me 4 days to paint a fence. That means in 1 day I can paint a quarter of the fence, right? Or if it takes me, I don't know, 7 days to drive to Maine, then I know in 1 day I can drive 1/7 of the way to Maine. So again, instead of talking about the number of days it's going to take, I say what amount of the work can I get done in 1 unit of measurement. Okay, so instead of having an x in my equation to say x days, I'm going to have a 1 over x in my equation to say I can get a 1 over x portion of the job done. And hopefully that makes sense, all right? If not, again, just follow along with this template. So y is going to be the same thing, all right? 1 over y. Again, instead of saying it takes me y days to do something, it takes me, I don't know, let's say y days to plant my garden, instead of saying that, so once again, let's use an example. Let's say it's going to take me 5 days to paint my garden. I can say that I can get 1/5 of the job done in 1 day, right? So again, instead of saying it takes me 5 days to plant my garden, I'm going to say in 1 day I can get 1/5 of the job done. So I'm representing these as fractions, and equations of this type are called rational equations, where we've got our variables in the denominator. Okay, now so working together, they get the job done in 12/7 of a day. Well, just like we didn't write our whole numbers here, right? We took the reciprocal. We have to do the same thing with 12 over 7. Again, I'm not going to burn up a ton of time in the explanation of this because I want to keep this video kind of short and convenient for you. But I would write this out as 1 over x plus 1 over y equals 7 over 12. All right? 1 over x plus 1 over y equals 7 over 12. My next equation, it will take, and let's switch colors here, it will take 2 times as long for the first painter to paint the ballroom than he would to paint the dining room, and it would take 3 times as long for the second guy than it would for him to paint the other room. If the painters work together, they can paint the ballroom in 4 days. All right, so once again, we are kind of reducing things to what can you get done in a day, what fraction of the project can you get done. All right, so having a little pen issues here. All right, so it will take him 2 times as long. So if this is what I use to represent how long it would take the painter to do his portion of the job, 1 over x, what's twice as long as that? Not twice as fast, twice as long. What is that going to be? Well, as you can probably guess, there's going to be a 2 involved, but, oops. But what am I going to do with that 2? Well, it's going to be in the denominator. It's going to be 1 over 2x. This is how I denote it's going to take me 2 times as long to do something. And likewise, with the y, it's going to take him 3 times as long. That's going to be 1 over 3y. All right, it's taking him that many times more. And it's kind of the same thing at play. You know, if I had written, well, it's going to take me 2x days to do something, it's going to take me twice as long. As you know, we take the reciprocal in these types of questions. So the reciprocal of 2x is 1 over 2x. If it takes me 3y days to do something, and I take the reciprocal, I get 3 over y. All right, and then I'm going to let you guys just fill in this last piece. Remember, we've been taking the reciprocal of everything. So if together it's going to take them 4 days to do this, what's the reciprocal of 4? What's the number I'm going to write there? And that's going to be my system of equations that I select. All right, let's move on to question 2. So, which observation about the correct system of equations is accurate? It is potentially solvable because the system has an equal number of equations and unknowns. It is not solvable because there are more equations than unknowns, etc., etc. So the first thing I would do is notice that these explanations are talking about the number of equations and the numbers of unknowns. Well, how many equations are there and how many unknowns are there? Well, the equations, you know what an equation is. Hopefully you can see that all the answer stems from the previous question. Those all had 2 equations, right? Those are all sets of 2 equations. You saw, you know, some sort of x and some sort of y, something equals something, right? Something equals something. Each one of those was an equation, and each system of equations had 2 total equations. How many unknowns are there? In other words, how many variables? And I'm going to let you answer that. How many variables are here? So once you know the number of variables, tell me, are these numbers the same? Are there more equations? Are there more variables? Hopefully that information will help you kind of narrow down your answers here and maybe kind of reason your way into the correct answer. And that's all I'm going to give you for this one. Let's keep going. Now you will use substitution to solve your system of equations in questions 3, 4, and 5. You can isolate the variable x in the first equation of the system you attained in question 1 to get x equals what? Okay, so ignore this line. We don't really need it yet. But we say we can isolate the variable x in the first equation of the system in question 1 to get what? All right, so I can't do this for you without totally giving away the answer. And it's important that you work on this and use your brain to do it yourself, right? We want to make sure that learning is taking place and then you get some time to practice with this type of equation. So what I'm going to do instead is solve a similar problem. So I'm just going to make one up, okay? Again, this is just something I'm making up to show you how you would do this. What you are going to do is follow the same procedure I'm about to, using that first equation, the more straightforward, simple equation that you obtained in question 1. All right, what I'm going to do is make up an equation. So I'm going to use a similar one. I'm going to use 1 over x plus 1 over y equals, I don't know, 2/3. All right, so this is just an example. Now they're saying I can isolate the variable x in this equation. So how do I go about isolating x? Well, there's more than one way. As typical for math, there's more than one way we can do this. I'm going to show you one way. I'm going to try to be kind of detailed, so this probably is not going to be the fastest, most efficient way to do this, but let's take a look. So I want to get x by itself. Typically we know by instinct when we are working with equations that if I want to get x by itself, I need to get rid of anything else that's on this side of the equation. So I've got 1 over y on this side of the equation. It's being added, so to get rid of it, I can subtract 1 over y from both sides of the equation. When I simplify, that gives me 1 over x equals 1 over y, or negative 1 over y, excuse me, plus 2/3. It's a negative 1 over y because I subtracted it and I moved it to the other side of the equation. And in fact, I'm going to rewrite this just to make it look a little bit prettier for me. 2/3 minus 1 over y. Alright, so again, I just rewrote the same exact thing. I just rewrote the right-hand side to be a little bit more tidy for my preference. The next thing I'm going to do, I'm going to choose to combine these two fractions. Okay, I'm doing this because I think it makes everything easier when you're dealing with less items, right? So right now I'm dealing with 1 over x, I'm dealing with 2/3, I'm dealing with a negative 1 over y. I think it'll be easier to just deal with something a little bit simpler. So I'm going to combine these two fractions into one little statement. Alright, so hopefully you remember how to subtract fractions that have different denominators. So I'm going to take 2 times y gives me 2 over y, minus 3 times 1 gives me 3, all over 3y. If you're not sure how I got here or you got a different answer, please review subtracting fractions with different denominators. Alright, so that gives me 1 over x equals 2y minus 3 over 3y. Well, my x still isn't isolated, right? I've got 1 over x, so that's not going to work. I just need the answer x. And here's where there is kind of a simple way to jump to the answer, but I'm going to take the long way, okay? So there's nothing I can do with this 1 over x other than multiply it by x, right? And at first this is going to seem like we're going backwards, but you'll see. So have some faith here. So I'm going to multiply both sides of the equation by x, all right? X times 1 over x, these x's cancel out, and I get 1. On this side of the equation, remember, I'm multiplying by x, so that just means that the x gets multiplied by the numerator. And in fact, I'm going to keep them separated. I'm just going to write this as x times 2y minus 3 over 3y. All right, continuing. Well, I see an opportunity to get rid of this fraction, right? If I multiply both sides of the equation by 3y and simplify, I get 3y equals x times 2y minus 3. And hopefully you can see from here that we are very close to our solution. I can now, I can see that this is being multiplied by x. This is what I need to get rid of to isolate x. I'm going to divide both sides of the equation by 2y minus 3. Now I have isolated x. There's not a ton of space, so I'm just going to rewrite this over here. Let's use this color. 3y, again I'm just rewriting, 3y over 2y minus 3 equals, notice that this fraction cancels out, equals x. So I got x equals 3y over 2y minus 3. Okay. Now remember I said I took the long way here a little bit. Notice that if I look back to this step, this is the reciprocal, right? So I had 1 over x. You flip that over, you get x, right? 1 over x, the reciprocal would be x over 1, or just x. I had 2y minus 3 over 3y, and now I have 3y over 2y minus 3. So again, just notice that I could have done this a little bit differently. I could have done a shortcut. I could have done cross multiplication. And if this extra explanation isn't meaning much to you and you like the way that I showed the kind of longer way with more steps, do it that way. But again, my answer here would be 3y over 2y minus 3. Now you'll do the same thing with your equation. You'll obviously have a different fraction over here, but the steps will be the same. And you would just write in your answer. So they said to get x equals what? So my answer would be 3y over 2y minus 3. All right, let's move forward. All right, now it says substitute your result, which I've already forgotten. What was it? 3y over 2y minus 3. All right, so I got x equals 3y over 2y minus 3. They're saying substitute this answer into the second equation in the system you obtained in question 1. So again, remember in question 1 you had to pick a pair of equations where I helped you find that we had something that looked like 1 over x plus 1 over y equals something, and then we had 1 over 2x plus 1 over, I think it was 3y equals something, right? So we already used up this equation. Now they're saying substitute what you got in the last question, in question 3, for the second equation from question 1. So what does that mean exactly? All right, once again, I'm just going to sort of make up an equation to show you what I mean. So let's say, for example, that my second equation had been 1 over 2x plus 1 over 3y equals 4 over 6. All right. So again, I already used this equation. I rearranged it to isolate x. Now they're saying substitute this into this equation. Well, first I'm just going to rewrite this equation bigger. So let's say my second equation is 1 over 2x plus 1 over 3y equals, oh, I just realized 4 over 6 isn't going to work. Let's do 4 over 9. All right, again, I'm just making up this equation. It's not the correct one. 1 over 2x plus 1 over 3y equals 4/9. So what do they mean by substitute? Well, you isolated x, and you said that x is the same thing as, whatever you got. For me, it was 3y over 2y minus 3. So that means that anywhere you see an x, you can take this phrase and you can plop it in its place. So for me, that would mean rewriting this as 1 over 2 times 3y over 2y minus 3 plus 1 over 3y equals 4/9. Now this looks a little bit hairy at first, right? But remember what I kind of touched on in the last slide, which was that, by rearranging everything and putting everything together, it turned out that I could just flip everything over and take the reciprocal, right? So if I take the reciprocal of all of this, I could just rewrite this. The reciprocal of this would be 2 times 3y over 2y minus 3 plus the reciprocal of this, 3y, equals the reciprocal of that, 9 over 4. All right, so if this step didn't make sense, feel free to try manipulating this equation first, or this form of the equation first. This is viable, remember, only if you do it to every piece of the equation. So you can't just randomly take the reciprocal of one piece of your equation and not do it to the rest. You have to do it to all your parts, as you know, to keep things equivalent. But this step might help you kind of simplify a little bit easier. All right, so that's what they mean by simplify and then solve. And then whatever answer you get for this, your y, remember y represented our second painter. So the x, the answer we got before, is in terms of y. This will actually give us a numerical answer because we have it down to a one variable equation. So this is going to tell us how many days will it take that second royal painter to paint the dining room by himself. Next, finally, you're going to get, in that last question, when you simplify, you're going to get y equals a number. So again, just making up an answer, let's say I get y equals 8. That means it's going to take 8 days for that first royal painter to paint the dining room alone. Now we know what y is, so we can solve for x. So they say substitute the value of y into one of the original equations. It doesn't matter which one, because y and x will have the same value for both, right? I would just choose the simpler one. So for me, if you remember my system of equations that I made up, my simple one was the one that looked like this, right? It's just a little easier to deal with. So all you would do is once again use substitution. So if y equals 8, that means anywhere I see a y, I can plug in an 8. So for me, that'd be 1 over x plus 1 over 8 equals 2/3. Then I would simplify just like I did the last time I showed you. Once again, I could say 1 over x equals 2/3 minus 1/8. I could combine, using combining my two fractions that have different denominators, and then I could isolate x, right? And you've already seen an example of that, and I think this video has gone a little long. I tried to keep them briefer. Anyway, hopefully that explained how to tell how many days it would take the first royal painter to paint the room alone. Finally, you are asked to briefly explain the steps you can use to solve this problem using technology. So we did this whole thing algebraically. If you remember, in a previous section you had in this project, you used a graph and then it said, well, how would you do it algebraically? Now we approach from the other end and we said, well, we did it algebraically, how would we do it graphically? I would recommend just start by graphing and see what you get if you're not sure. So graph that system of equations from the first question. Start by doing that and just kind of see where that takes you. Once again, as you know, think of this like a discussion post. Use the discussion post rubric when you're answering this question. Use proper mathematical language and explain it as if you're talking to an audience that really doesn't understand what's happening. Again, it's okay if not all your ideas are correct. If you're wrong, you're still going to get points. I'm looking for a well thought out response, a clear succession of thoughts and conclusions, okay? All right, so hopefully that helped you with section 3 of project 1.